So now we're going to talk about projections and vector components. So we're going to start by defining what a projection is, and then we'll look at a picture so we can visualize what a projection is. So we're going to let U and V be non-zero vectors. And then what you can do is you can write U as the sum of two vectors, W1 and W2, where W1 is parallel to V and W2 is orthogonal or perpendicular to V. So you can break U up into these two parts right here. You can break it up into two vectors, and the first vector would be parallel to V and the second vector would be orthogonal to V. So we're going to give names to these vectors. So the first one, W1, is called the projection of U onto V. Projection of U onto V, which is denoted by, so W1 will be also written as projection. So you have the vector U here, and then you have this subscript, which is the vector V. So it's the projection of U onto V. And then that second vector, which was W2, which you can also find W2, it's U minus W1. This is called the vector component of U orthogonal to V. So let's look at a picture here. Let's say I have my vector V here, and then I have my vector U here. Ideally, I should draw maybe a little bit straighter of a line here. Oh, there we go. So what I can do is I can project U onto V here. I can split U up as this vector. Here's W1, and then this vector here, which is W2. And you can see that this first vector is parallel to V, and this second vector is perpendicular to V. Okay, so let's try to find these. So let's look at the following example. Let's find the vector component of U, which is going to be their vector 5, 10, that is orthogonal to V, 4, 3, given that W1, our projection of U onto V, is going to be the vector 8, 6, and U, 5, 10, is the summation of W1 plus W2. So there's a lot being said in this problem, and it might help if we first see what is it asking for me to do. If I go back here, I'm asked for the vector component that is orthogonal. So what they're asking me to find is this W2 right here. So W2, I can find that by taking U and subtracting W1. In this problem, U was the vector 5, 10, and W1 was the vector 8, 6. So I can subtract these two vectors together and get negative 3, 4 as my answer here. And you might want to check. Remember that this vector needs to be orthogonal to the vector v. So let's check that. Let's check that W2 is orthogonal to the vector v. So the vector W2 is this vector negative 3, 4. The vector v, they told me in the problem what was v. It was 4, 3. And the way you check orthogonal is you need to check that the dot product is equal to 0. So let's take the dot product of these two vectors together. And what do I get? I'll get negative 12. So positive 12, I get 0, which is what I needed to happen. So these two vectors are orthogonal. And there's my answer that I had back up here.